Okay guys, listen, I'm going to go through a problem-solving strategy for writing delta epsilon proofs. So follow along because this is going to help you. And again, we're going to do more examples. So again, this is going to help you approach this in a nice, organized, systematic fashion. So, number one, you always want to start your proof with let epsilon be greater than 0. Okay, I explained why earlier, but epsilon is greater than 0. We want a positive epsilon, right? So we're going to say, okay, let epsilon be greater than 0. Then 2, we need to obtain a value of delta. This is where your scratch work comes in, right? This is where you're trying to find what you need to choose delta to be. After you obtain that value, you fill in the blank with our choice of delta, right? That's where you say choose delta to equal whatever, okay? So use first line, let epsilon be greater than 0. The next statement, choose delta to be whatever you obtained for it through your scratch work, okay, through your analysis, right? That's what we call the analysis part. Okay. Let's see here. Yep, am I missing something? No, I don't think so. I just want to make sure. Hold on. Right, okay. Okay, so yes. So we're doing our scratch work, and then we're going to do the analysis part in our proof, okay? So, scratch work comes in part number 2. After you've got your delta, you're going to write the statement, choose delta to be whatever. Then step 3 is your next line of the proof is going to be your assumption. You're going to assume that 0 is less than x minus a, the absolute value of x minus a less than delta. Okay, that's it. And then 4, based on what your assumption 3, this is where your analysis comes in, based on your scratch work. And so what you're going to do is you're going to use this and manipulate it algebraically, basically going backwards in your scratch work. If you noticed that in the last video, it's kind of working your way backwards in the scratch work. So, and what happens is by manipulating this, you're going to get to the point where you have this, okay? And that's what I'm saying here. We use this to get us there, and this is where your scratch work comes in. Now, once you get from here to here in your analysis, you're done. You've proved what you needed to prove, and therefore, we conclude that the proof with therefore, these triangle of dots is the symbol for therefore. So therefore, the limit as x approaches a of f of x is L. So these 5 steps, make sure you use them. These are key to doing a good proof and doing it right on a quiz or an exam. Okay? So now let's do some examples and see it in action.